Welcome to another, I know it's been a while, iteration of Wise Ass Water. I'm Marvell.
Sorry. Janelle.
Jeez, what was that?
I'm sorry. I'm tired.
I'm going to leave it in there. I'm not going to cut any of this out. It's going to be raw footage. So,
it's been a long day.
we're going to go over, well, actually, she did a presentation out at the Missouri Rural Water Conference. She was asked to go out there and do a phosphate presentation, which I think that's what we're going to show.
Yes, we're going to go through that.
We're going to go through that, and then,
yes.
you know, always, if you have questions, please don't hesitate to contact her, because she is, her and her mom, I say Yoda, her mother, and her as in...
His breath stinks.
Really that bad?
What if...
Ponscone?
Oh, yeah.
Oh, ball.
Yeah, he got that ball.
Oh, yeah. So,
sorry.
Watch the video, tell us what you think, and then,
oh, gosh.
we look forward to hearing from you.
Yes, absolutely.
So today we have Janelle Summerow.
Yes.
And she's going to talk to us about phosphates in drinking water. Why does that matter? Because it's corrosivity for lead and copper. So we're going to hear from them. And I hear if you answer questions, see you guys are here now, so you'll know this trick. If you answer questions, you get a ticket. I'm not sure what the ticket's for, but participation counts. So we'll see what happens. Thank you.
Hey guys, can you hear me okay? All right. Well, my name is Janelle with Waterwise Enterprises. Just to give you a little bit of background about us, we've been in business since 2002, and we're out of Oxford, Kansas, which is really on the border of of Kansas and Oklahoma. We are a family-owned business. We specialize in phosphates, but we sell water treatment, wastewater, lift station, pool spa chemicals. So we just kind of have a whole line of things that we do. So I definitely want to say thank you to Missouri for reaching out and asking us to present today. She was correct with the tickets. One thing that we're going to do is this lovely lady right here. Raise your hand, lovely lady. We're also going to call her Yoda, because if I can't answer a question, then she can. She's going to hand out tickets to anyone who answers a question that I ask or ask a question. And when you come to our booth at L5, then you will get a gift. You can just give us that ticket and exchange it for a gift. And I promise it won't be for one of the free items we're giving out to everybody. It's going to be for something different, okay? So it'll be worth your time. The other thing that my husband's doing right here, he is filming for our podcast. So if you ever get bored as you're driving, reading meters, or whatever you're doing out there, you can listen to Wise As AZZ Water on YouTube or Apple Podcast, and you can laugh as we try to, fumble through some things that go on as being water operators. The other thing that might sound different is it's going to sound like I'm reading. That's because I am. I am fairly new to presenting, and there is a lot of information that I wanted to make sure that I don't forget. So as when anyone's nervous, you like to talk fast and fumble through things. So I am going to read a lot of things because I want to make sure that you guys do leave here with as much knowledge as possible. So just bear with me, please. So we're going to cover Phosphates 101, different types of phosphates, what phosphates used for, optimal dosing, the importance of flushing, and finding a reputable phosphate distributor. So one thing about Phosphates 101, we're going to go through where do phosphates originate, and are they safe to put in our water? That is something that I get asked quite a bit when I'm before city councils or board members when they're looking at introducing phosphates. I know she had mentioned phosphates for corrosion control, but we also use them for sequestration of iron and manganese as well. Then, are they safe to handle? I've had board members really concerned. They've heard it through the grapevine that phosphates are unsafe, that they were really worried about their operators handling them. So that's another thing that we're going to touch base on. Different types of phosphates. So here's your opportunity for a ticket. Does anyone know what types of phosphates go in water or are used for water treatment? Orthophosphate, very good. Come on, Vanna. Anyone else? Yeah, very good.
Don't make me run.
Anyone else? We have two more. There you go.
That's good.
Uh-huh. And we got another one?
Is there a tripolyphosphate?
No, but close. You get a ticket just for participating.
What was that mean? Meta.
Very meta, very good.
Meta.
Very good, very good. So that was the other thing. So just to review them, you have sodium hexametaphosphate, tetrasodium polyphosphate, or pyrophosphate, sorry, orthophosphate, and polyphosphate. Those are the 4 phosphates. So we're going to review those 4 types of phosphates as well. And then we're going to talk about what they're used for. We're going to review the primary uses for water, like I talked about, corrosion control and sequestration, and some other uses for phosphates as well that aren't for water. Optimal dosing, the breakdown for sequestration and corrosion control, and introducing phosphates into your water, why it's important to monitor that as well. And importance of flushing. A lot of people think, why am I going to flush? I'm just wasting water. Well, that's a very common misconception. Flushing is very, very important, and it's also one way to do preventative maintenance. So we're going to talk about the benefits of flushing as well. And then finding a reputable phosphate distributor. Your distributor shouldn't just be dropping off chemical and walking. You know, there's a lot more that a distributor needs to play in the role of treating your water, helping you treat your water. So this is a quote that I found from United Nations that really just, I don't know, spoke to me about operators, so I'll let you read it. So I chose this quote because your role as an operator is extremely important. The integrity of your work, accurate data documentation, error correction, reporting, as well as following procedures are crucial to your health and well-being. Please do not underestimate your significance and always prioritize the quality of our drinking water by managing the complex process of water treatment, distribution, and adhering to government regulations. As we all know, with the EPA changes and guidelines, things are not getting easier for you guys out there. They're getting more complex. So I don't think operators get anywhere near the recognition that you should for what you do and for the many roles that you play. So I just want to say thank you for everything that you do. So this is a phosphate rock. It's used to produce phosphorus and phosphoric acid. Okay, another opportunity. Does anyone know how long ago phosphate originated?
A long time ago.
Anyone? Anyone?
Then we started putting in drinking water, or?
No, just where how long ago it was discovered, or yeah. Think prehistoric.
Millions of years ago. Millions of years ago. Millions of years
Yeah.
ago.
A few billion.
Something M period? I don't know.
No, he's close. Million
Millions of
years ago.
Yeah.
I still
Yeah.
don't understand you.
Stop.
The other guy
I said-
too in the
I said a
den.
million years
Back
ago.
in the
Million years ago?
Million years ago, yes, him as well. Okay, so does anyone know what phosphate is an accumulation of?
Sediment.
Calcium?
No,
What?
it's not.
Uh-oh, Yoda screwed up.
But you still get a ticket for participation.
Hey, give me better information next time.
Yeah, it's a good cheat.
Sediment.
It is actually animal skeletal remains, organic matter, dissolved phosphorus in seawater, solidified and settled at the ocean's bottom, forming sedimentary rock layers. That's what it's accumulation of. And it's natural compounds, so salts containing phosphorus and other minerals. Phosphates Phosphorus occurs naturally and is often found with other minerals like calcium and sodium. There's your calcium. And it comes from phosphate rocks mined from the earth. The rock is crushed and purified to form phosphoric acid, which may react with caustic soda or time to produce purified phosphate salts. So we asked the question, are phosphates safe to put in our drinking water? So they're natural compounds, and believe it or not, your bones and your teeth are types of phosphates. With the scientific name of I struggle with this one. Hydroxyapatite, which is 97% of our tooth enamel. And tricalcium phosphate, or aka bone phosphate of lime. So phosphates are used in various applications and consumable items. The National Sanitation Foundation certifies phosphate products used to treat drinking water to NSF and NSI standards, 60 standards. So the standard drinking water treatment chemicals health effects was established to ensure that treatment chemicals and any associated contaminants will not cause adverse health effects when dosed at the product certified maximum use level in drinking water. And the distributor helps play a significant role in that. The EPA reports on the website that typical phosphate levels in a liter of drinking water are about 100 times lower than the average American diet. For example, a person would have to drink 10 to 15 liters of water to equal the amount of phosphate in just one can of soda. So, to let you guys know, yes, phosphates are safe. What we put in your water is such a minute amount that it's definitely safe. You're going to get more phosphate from drinking a can of soda than you would from what you're drinking in your water. So, like anything, phosphates are safe in moderation, and anything in excess can be harmful. Most lines of phosphate are considered non-hazardous, but you have to take caution when you're handling a couple lines of phosphate for corrosion control, like zinc ortho. It's considered hazardous, so you just want to be very careful when you're handling it. Or phosphonate is another one. Again, it's considered hazardous, so you want to be very careful when you handle it. I said that. Huh? Oh, also orthophosphate. Sorry, Yoda was correcting me, everybody. Orthophosphate too. Thank you, Yoda. Again, you're introducing such a small amount into the water system, it isn't harmful to your drinking water as long as you adhere to your engineer, distributor, or consultant dosage rates. Okay, so here's another opportunity for you guys. So I'm going to ask you about different types of food, and you tell me if there's phosphate in that food. What about eggs? Is there phosphate in eggs?
Yes. I think so, yeah.
No. No, there's not. Where's my ticket, lady?
I'm sorry.
You're talking.
You said what?
Raise your hand if you spoke, please, so you can get a ticket.
Well, I was wrong though.
It doesn't matter, you're participating. Okay, so what about minced garlic?
Yes.
Yeah.
Yes.
Yes, there is.
Listen to me.
It has phosphoric acid in it.
You got one here. One up
And we're
front.
not going to go with the Rice Krispies, guys, because for some reason I did not realize it was circled when I put that on there, and the answers aren't there. So you can see it has ferric phosphate in it. What about apples?
No.
No.
God, I'm just bad.
He's a-
And what
yeah.
about pumpkin seeds?
Yes.
Yes, very good.
Who said-
Yes,
okay.
it has, does have phosphorus in it. So good job. So on this next slide, we're going to talk about some food additives. So on your 8-ounce can of Coca-Cola, does anyone take a guess about how much phosphate is in 8 ounces of Coke?
It's 60 to 120. No, 60 to 120.
60 to 120.
58.
Oh, it's
You got to get it right, Marvell, if you're going to cheat.
I'm trying.
I knew that one too.
You need to help some of these guys
Oh,
up front.
I'm coming up
okay?
here, I'm coming
These guys
here.
up front need some cheating love over here. What about cheese? Just 1 ounce of cheese.
100.
100.
That's, yes, 120 to 250 for 1 ounce of cheese of phosphate. And donuts?
120 to 2, 100 to 120 to 150.
5.
120 to 150.
Here.
120
120
to
to
150. Say it. What was it?
120 to 150.
There you go. That's right. Yep.
I can hear somebody. Give them a ticket.
Very good. So just to let you guys know and to ease your mind
in
about
milligrams?
phosphates, you're getting so much more phosphate just from the food that you're taking in every day than what you're getting from the water that
What
you're
she said
drinking.
is like
So then some additional uses for phosphate is pharmaceutical. So in pharmaceutical
Right, yeah.
preparation, phosphates are
that's-
used
they're
both
used in
as an
everything.
active pharmaceutical ingredient, such as biphosphonate, and as a drug cantarian, betamethasone sodium phosphate, or most commonly as an excipient, which is anhydrous calcium hydrogen phosphate.
Here's a question.
Yes, sir.
Why are they putting it in there? Why are they putting the phosphates in the Coke and then on the cheese and stuff? What's the benefit of that?
Yoda,
It's preservative.
Preservative, okay.
she's so handy. So if anyone didn't hear that, he asked why they put phosphates in there, and it's because it's a preservative.
Well, no, I take it.
That's why. Very good question. So for detergent, the advantage of using phosphate in consumer laundry or dishwashing detergent is it makes the detergent more efficient by chelating calcium and magnesium ions. So that's the use for that. And then for phosphate and primary nutrient commonly used in fertilizer, does anyone know what the other two nutrients in fertilizer is?
Nitrogen and.
Potassium.
Potassium?
Very good, nitrogen and potassium.
He said nitrate.
Okay, good job. And then you have it as a filter aid. So phosphate works on filtered media because it coats all the individual media, allowing nothing to stick. So when it's backwashed, it comes off cleaner. But it has to be fed at a very low dosage rate, very, very important, like at a quarter parts per million, or everything will get through. And you have to be very careful careful if you use phosphate for this process by monitoring your turbidity in the clear well. So that's something you really need to look at if you use it for that reason.
Wasn't phosphorus limited or eliminated from laundry soap and dishwashing soap and things like that years ago?
I don't know, do you know about that?
They used to put a lot of phosphate in, like spick and span, and it's kind of, they call it clean and clog, because it's very hot, very quick, and then it just doesn't do it. So they did use a lot, I think they're still a little bit used, but not much out there as much.
And I think in the late '70s is when they pretty much eliminated.
You think it's totally eliminated now?
Not completely, but
Yeah.
I do remember they cracked down on it fairly heavily.
And that had a lot to do with what you're talking about, the NCLs going out of place like.
Did everybody get that, or do I need to repeat any of that? I'm so glad, because I didn't get it all repeated, so I'm glad. Okay. So on here, we're going to talk about the phosphate in water, which is used for corrosion control, sequestration, chelating, filter aid, air strippers, and then the chlorine residual for cleaning and biofilm. You'll see on this one right here, tuberculation. This is a very common thing you can find as you're repairing pipes, and I bet all of you have seen this, where you have like 6 inches in diameter, and it's so full of metals, the lead, copper, precipitating out into distribution, that you might have a 2 inches to where the water can flow through. So you're definitely not getting the full benefit of your pipeline. What the phosphate does is it puts a coating on there like that. So therefore the metals can't leach. Make sure I don't fall, you guys will get a really good laugh. The metals can't leach into the water and build up on the pipe the way it is right there. So then we'll talk about corrosion control. So just remember for the following information, which it's been drilled in our head over the last 3 years, the LCRR and the LCRI, that's the health effects of lead and copper, impaired physical, mental development, brain, kidney damage, injury to red blood cells, abdominal pain and nausea. When copper leaches into the water system, it can have a metallic flavor or a blue to green discoloration on the surface. And when you introduce phosphate into the water system as part of your water treatment technique, it's going to prevent the leaching of the heavy metals by putting that protective layer on there. The other thing is when you're looking at corrosion control, it doesn't matter whether you inject bleach or phosphate. You can do bleach first, phosphate first, it doesn't matter at all. When you're doing sequestration, that's a different story, and we'll get to that when we cover sequestration. So what causes corrosion in the water? Anybody know?
Metals?
Yes. Yep. You do have, acidity is right, whoever said that. Metals, correct? Any other? Uh-huh, yes.
Whoever answered, raise your hand. I lost track.
Yeah. You hear? Yep, correct. And you have TDS, total dissolved solids, high flow rates, and dissolved gases like oxygen and carbon dioxide. So that's what causes corrosion. When all of these factors are combined, the corrosion is accelerated in your water system. So phosphates again help because such as phosphoric acid, zinc phosphate, sodium phosphate, polyphosphates can be added to the water to create orthophosphate. And that forms the protective coating on the inside of the piping system, and the coating prevents the corrosion of the pipe and releasing of the metals like the lead and copper into the drinking water. And in sequestration, of course, sequestration is for your iron and manganese, so your black water and your red water. And then it also helps with scaling, which we've seen before on this next slide. I'll show you. Oh, not that one. Whoopsie, sorry. Oh gosh, forget it. We'll go to that one later. The scaling, you guys know what scaling looks like. I'll show you a little bit, but it helps with that too. The chemicals are added to the water at the wellhead or the pump intake. The water has had, before the water has had a chance to come in contact with air or chlorine. That's really important. So with sequestration, you want to make sure you feed your phosphate before you feed any kind of disinfectant. And you want to at least have 4 feet minimum in between the two. You want it to be able to definitely blend with the water. The more time, the better. Yes, you in the back, Yoda.
You might also mention that if their well is far away from where they're chlorinating, they need to move the phosphate to the well so that it can, if it's traveling miles down the line to the chlorine mill, it's taking the
Tied up
sequestration.
before it gets there.
Pardon?
It's tied up before it gets there.
Yeah.
Did everybody
It's
get that?
Just the air in the
Yeah.
line will make it fall out.
Did everybody hear that okay? Okay, perfect. Thank you. Okay, so just to explain a little bit about the sequestration. So what it does is, as the phosphate goes and it covers the line, because pyrophosphate is a dispersant, so it's going to go and it's going to cover the line. And it's going to start your iron and manganese is going to attach to it, and they'll stay on there for about 30 days, and it's just going to drop off, and it's going to be held securely, and it's going to travel through the water system so it can't be seen. And then you're going to have another piece that's going to go up there, and it's just going to continue to do that the whole time until it completely cleans your lines. So it's not a very fast process because you don't want it to be too fast, otherwise you're going to have customer complaints. They're going to have some dirty water. And that's another reason why your flushing is so important whenever you're feeding phosphate, because you're cleaning those lines, you need a way to get it out, and you really don't want it to be through your customers' houses and their piping. So that's one reason why you want to flush. You can also use it as a filter aid. You can use polyphosphate, sequestrant, and dispersant for this treatment as well. Air strippers. Phosphate is for reclaimed water only. It has organic material and can only be flushed into non-potable water such as rivers and lakes. Then for chlorine residual, you want to maintain chlorine quality standards mandated by the EPA or your state. Air is essential for preventing illness by disinfecting tap water. Water pipes can develop a slimy layer of biofilm that protects germs from being killed by disinfectants, which I'm sure we're all familiar with. Chloramine will not kill the biofilm, it will only make it dormant. Only chlorine will. So therefore, some may need to switch from total to free chlorine. If you cannot maintain a chlorine residual in your distribution, notice the taste or odor problems, I definitely recommend purchasing like a BART, slime, or iron-related bacteria or sulfate-reducing bacteria kit. You can just usually test your water, see if it has some kind of biofilm in there. Does anyone know how to treat a biofilm in your distribution?
For chlorine, let it burn it out with chlorine.
Perfect, yes. And then flush. And then if you have the standpipe, water tower, clear well, you definitely want to make sure that that is treated as well.
Oh, sorry.
So the way a phosphate works is from the bonding of ions on molecules. Phosphates have several defining characteristics, including molecular structure and pH, which is usually a 1% solution. The characteristics determine how phosphates function and are used. Phosphates can provide buffering strength, sequestration or chelating power, dispersion, and absorbent capabilities and solubility. They're commonly found as compounds or phosphates ions combined with elements like sodium, calcium, potassium, and aluminum. Phosphates have many great qualities, including the ability to keep compounds that normally want to separate from each other. They can bring together and keep substances that would usually separate into layers. So phosphates are grouped based on the number of phosphorus P molecules, and each group has functional properties suitable for various applications. And here we are into the types of phosphate. The sodium hexametaphosphate is a sequestering agent that removes water's hardness by combining it with metal ions such as calcium, magnesium, and iron. Also known as glassy plate, it is a complex phosphate glass produced by a thermal process from soda ash and food-grade phosphoric acid. Tetrasodium pyrophosphate helps stabilize and maintain the desired pH range. It's used in metal finishing and water treatment for lead control, red and black water sequestration, and is a powerful dispersant. It will clean lines very quickly, so you don't want to start feeding at full dosage. You definitely want to start feeding at half the dosage. And then you want your distributor to test the water within a couple months. Then from there, turn up your dosage a little bit, retest it. There's a couple reasons for that. One, you might find that you don't have to use the full dosage rate. You might be able to hit your goal with just 3/4 of the dosage. And then also will save the customer money as well. And then polyphosphates are crucial in stabilizing water quality by minimizing color, scale, and deposits on water lines and controlling corrosion and chlorine demand. They act as dispersants, chemicals used in water treatment to break down and disperse particles, preventing them from aggregating and settling. Orthophosphates are available as phosphoric acid in salt form, potassium and sodium, and as zinc phosphate. It reacts with lead and copper to form compounds that strongly tend to stay solid and not dissolve in water. The extent to which orthophosphate can control lead and copper depends on the phosphate concentration, the pH, the DIC, which is the dissolved inorganic carbonate, and the characteristics of the corrosion control scale. So whether it contains other metals as iron, yes, sir.
No, finish it, it says.
Oh, iron or aluminum.
So, the tetrasodium pyrophosphate is trisodium phosphate, a sub of that. Like when they go to paint a water tower, they wash it down with TSP, is called trisodium phosphate. It's a cleaning agent. So it sounds similar to that. Is that, do we know? We're shaking our head yes.
I like how you're looking at Yoda, because that's perfect.
I saw you looking first.
No, I think it's great. You know where to go.
Thank you.
That's a very good
So is
question.
it part of that? I mean, that's, I guess, where does it fit in there?
A pyrophosphate is made from potassium.
Okay,
And, as she was saying, it's extremely effective in sequestering iron and manganese. But it's also such cleaning abilities that it will scour.
but that's what they use it, I mean, you know, you can't always
It'll test
surface
it.
prep the exterior of a water tower, so they'll wash it down with what's called trisodium phosphate, and the tetrasodium is really close, I just asked them if it was
Yeah, it's very
subspecies
good.
of that.
They use it a lot in metal finishing.
Which would make sense, water towers.
That's a very good question.
Yeah, here, take two.
Okay, we might be into giving you guys the free stuff. Okay, on this side, guys, we're gonna be talking about sequestration. You've got your your iron right here, then you have your tuberculation, and then you have your scaling over here. So we know that iron bacteria can naturally occur in soil and shallow groundwater. They combine with iron or manganese and oxygen to form deposits of rust, bacteria cells, and slime that adhere to pipes, pumps, and plumbing fixtures. It can also be introduced when the wells are dug by not chlorinating all materials used or superchlorinating the wells after. So that's one thing that I found really common with some customers is, you know, they'll tell me, hey, I'm having a really hard time holding my chlorine residual. And that's one of the first questions that we'll ask them. Have you had any wells worked on? Have they been, you know, rehabbed? Have they been pulled? Anything like that? And a lot of the times they have, and they didn't get super chlorinated or something, which allowed for bacteria to get in there, and that's one of the reasons why they are struggling with their chlorine residual, because now they have a biofilm in there. Superchlorinating. The process of superchlorinating followed by dechlorination involves applying chlorine to the water to produce a high level of free residual chlorination. This excess free chlorine necessitates dechlorination before the water is used, and the process is recommended for disinfecting highly polluted waters for drinking purposes. And then we're going to talk about dosing. So when we're looking at dosing, or when I look at a customer, I'm going to look at their water analysis, their inorganic water analysis. I'm going to take a look at their hardness, their iron, their manganese, look at their head pressure. There's all kinds of factors that I take a look at before I know what type of phosphate to set them up with, whether they're failing lead and copper, or if we're just looking at a sequestration, or we're just looking at a corrosion control. Because we have phosphates that will just do one or the other, or we have phosphates that will do all of it. Then you're also going to want to make sure that you're feeding the right part per million. So based upon their gallons per minute. You want to also look and make sure that you're putting the right equipment in there. I have seen other people put in a Stenner pump. So I love Stenners, big advocate for Stenners. But we know if anyone uses them, they cannot handle anything more than 99 PSI. Anything more than that, you're going to be blowing tubes, you're going to have a big mess. So I have seen other people put in Stenners when someone has 140 PSI and they're not understanding why they're having so many issues with their equipment. Well, that's where your distributor comes in. They're going to know this stuff, and they're going to make sure that they set you guys up with what your system is able to handle and what phosphate works best for you. And also with the point, if you try a certain phosphate, it may not always work out the first time. And then, being able to willing to continue to try different lines of phosphate as water quality does change and nothing's uniform. There's a lot of elements that go into that. So there are many factors when looking and determining when phosphate to introduce. Again, you want to start at half the dosage. That's really important because you just don't want to clean those lines too quick. We don't want to cause you more problems. So that's one thing. And then we also want to make sure that we're not having you as customers spend more money than what you need to. If we can go in and have you just feed at half the rate or 3/4 of the rate, well, that's a win-win, for you guys as well. So, and sequestration is usually half the dosage of corrosion control whenever we're configuring everything in for the calculation. I thought it was sequestration.
Corrosion can normally take less.
Oh, my apologies. Switch that, please. I'm just checking your knowledge base. Good job, Yoda. Good job. You caught that. Good mistake. Where am I going? I don't know why I keep wanting to. Oh, flushing. Everyone loves flushing, don't we? So we definitely recommend 2 times a year, in the spring and in the fall. Water main flushing moves water systematically through sections of water distribution. A scouring action to clean the lines. The increased flow rate scours the water pipes' inner walls and helps to remove the buildup of naturally occurring debris and sediment. Very important too, because if you are cleaning those lines, you need that stuff to get out of there. You don't want it to build up. And it again removes the buildup, and the water is discharged onto local roads or other surfaces through the fire hydrants or flush valves. And this is not wasting water, guys. This is something that's preventative maintenance. So it's something that I know other customers that I've had have had a hard time. Their residents complain. They don't understand why. They see water just being dumped on the ground. But if you're able to explain it to them, hopefully they have a better understanding. Okay, does anyone know the importance of flushing? Anybody?
Clean your lines out, it's a
Yeah?
big thing.
Keep rushing water in the lines.
Oh, test your fire hydrants.
Yeah, very good.
Reduces your chemical requirements.
Mm-hmm. Yeah.
Flush dead ends to keep chlorine levels good at dead end.
Yep. Absolutely.
Just wanted to take it.
Anybody else? Reduces biofilm, and I think you guys covered everything. Oh, the other one would be allow the assessment of the flow rate available for firefighting purposes. So good job, everybody. Another one says, anyone want to tell me or tell us how you flush? Do you guys have a certain
from the water tower out.
He gets two for that one. Everybody misses it.
Very good.
But it's also good if you can get a hydrological study of how your water goes, you know how to flush then.
Mhm.
And that was a big thing for us, so we had to get that before we knew where to go to flush it away from the tower.
So you
Yes.
flush it downstream.
Yeah, yeah.
It's always a really good idea is once you start flushing, if you keep the water flowing in the same direction all the time, so that you're not pulling and scouring back and forth.
Yep.
Sometimes it's hard to do if you can't get it done in a day.
Yeah. Very good. Well, you know what? You guys just knocked out a whole page. Way to go. All right. So finding a reputable distributor. Definitely more than just a delivery company. You guys want to make sure you have a consultant, again, that they're going to put the right chemical and the right pump into your facility, that they're going to help you with the setup. You know, they're not just going to deliver it and leave you. You know, they're going to be available to you, that they have the education, the experience. As you know, there's so much to learn that I'm what you call a YIT. I'm a Yoda in training, obviously. So everyone has a Yoda. You know, I don't always have the answers, but it's not about that. It's a matter of me knowing who to call or networking. Calling your Missouri Rural Water District, calling some other people that you know that have more experience in that. It's okay to not have all the answers, but just knowing that you're going to get the right answer and being able to find that for your customer. And 24 access for problems. Unfortunately, water problems don't just happen Monday through Friday from 8 to 5. You know, as you guys know, they like to happen on the weekends, in the middle of the night, all that kind of stuff. I have had to meet customers at 10 o'clock at night because their pump went out. I mean, it's not convenient, but you know what? They can't stop. And so we can't stop. So you just want to make sure you have that kind of a person, that kind of a distributor that will be there and support you through the good and the bad. And guess what, guys? You made it. Good job. Does anyone have any more questions? Yes, sir.
I've got a question about a well, if anybody's had experience with manganese and iron in a well, or like, it's a non-chlorinated system. The well just serves one, facility. They don't use a lot of water. But this well has got, it's got a filtration system where the water comes into the building and serves, and it's just, it's a black color. And I asked the water operator if they super chlorinated, and didn't really get a response. So iron and manganese like that is one of those phosphate treatments a method for helping a well like that?
Well, yeah. I mean, go ahead, Mom.
Well, yeah, it is. The problem that you'll have is Missouri doesn't require any chlorination.
Right.
So, with him having a filter, I don't know how big the system is.
It's small.
If they have an inline water filter, what happens is that manganese and iron starts producing bacteria on that filter, and that's what you're seeing clogged. Once it's clogged, it's not filtering anything, it's just clogging that. So you could put a phosphate in there, but you would also have to chlorinate it at the same time.
Shock it, you mean? Shock it
But
well?
if you're gonna feed a phosphate, you have to feed a phosphate return every time. So if it's like 50 gallons, so it has to be able to feed enough phosphate for that 50 gallons going through the line. But you cannot feed phosphate without a chlorine, because phosphate it'll feed bacteria if it doesn't have chlorine in it. So you're kind of stuck between. No, man! No! 12-24 hours, you can throw a gallon of chlorine in there and do the same thing. Just let it circulate. Open up the hot water tanks, let them drain out, and turn on your taps until you don't smell chlorine anymore. And they might have to do that.
Several times to
I'm
get
sorry?
that.
Turn the water heater off first.
Yes.
Yeah, good idea. Okay.
Thank you, I
Okay.
appreciate that.
We have her for 20 more minutes. Does anybody else have any questions for her? No. I mean, yet. I'm working. No, in all sincerity, guys, I really appreciate your patience, and I hope if you have any questions, you won't hesitate to reach out and ask. Yes, you in the back.
Make sure you stop by our booth.
Oh yeah, L5 guys. Sorry, collect your gifts if you got tickets. So yes, thank you very much.
Thank you.
Thank you.
So you got to see the video, folks. How'd you feel?
Nervous.
Nervous?
I was very nervous, yes.
There were some good questions, all right?
Very good questions, yes.
Awesome.
That's what makes me nervous is the great questions people ask.
So it's not like it was for knowing the information. Did you see that there was a very good in doing the show that there was a good showing of people that were very interested in phosphate?
You know, honestly, I found that there is a lot of people that don't know a lot about phosphate. They have a misconception about it, thinking that it's harmful. And then I also realized that, you know, a lot of the phosphate knowledge I have is based upon Kansas. And every state, it's different. You know, like in Missouri, they have to really look at the phosphate that shows up in their wastewater. That's a big concern for them. In Kansas, it's not really a big concern for us. So it's just unique to see in different states, you know,
What they're looking at?
Yeah.
And was it one of those things like they think that the amount of phosphate that's being fed is going to influence their wastewater?
Yes.
Do you, in your opinion, do you think that that's going to be a big influence? Or is it such a minute level of phosphate that's going through? It's not like it's a quick solution. It takes time for the phosphate to work. So will it affect it on the long run? I mean, I know that phosphate's found in even toothpaste, a lot of different things. Soda pop, stuff that's getting flushed all day long. So how does making your water better or the pipes better going to influence it down the line if you add
Downstream.
phosphate?
I don't know. I would have to honestly dig further into Missouri's water analysis, get more information, because their wells, their aquifers are so much deeper than ours here in Kansas that I would just need to dive deeper into their water analysis and see what it says, and on the back end too, downstream, and see what their wastewater information is and go from there.
Oh, that's good.
Yeah, it's kind of hard for me to say yay or nay without seeing the data.
Awesome. Well, folks, there you have it. Phosphate, definitely a big thing for WaterWise.
That's our specialty.
And she loves to go and talk, even though she's nervous. She says she
my
is.
gosh.
She actually was. The presentation was really good. I'm just gonna be honest. It was actually really good.
You guys will see that. Thank God Yoda was there. I can deliver the information, but like those questions were good. They were really good.
Yeah, it was good. Some good questions.
Yeah,
But
they were good people.
again, like, follow, share. Write us a note. Let us know if you have a specific topic or a question that you have regarding phosphate. Her phone number will be listed. We have an information line. We also have info@waterwiseenterprises.com. And let me spell it out. Waterwise, W-I-S-E, enterprises.com. Thank you, Mom, for the long URL.
Yes.
And then come to our website, waterwiseenterprises.com. Facebook.
And I have a
You got a LinkedIn account?
LinkedIn.
You know,
well,
if
it's
you-
under my name.
Yeah. But
Janelle
still, I mean, you
Summerall
can
at
follow
LinkedIn.
some of the stuff that she does on there.
Yeah.
Very, very good business. What would I say? Business networking.
Yes. Yeah.
Yeah.
Definitely have. It's definitely expanded our network.
Yeah.
Yeah, I learn a lot from the people on LinkedIn.
Yeah.
Yeah, a lot of good information on there. I would say definitely send questions. I learn from your questions. If I don't know, then it just expands my knowledge as I reach out to find out answers.
But
know?
you know a lot of the questions and answers, depending on.
Depends.
Yeah, there's some tricky ones.
Yeah, there are, and I always have a lot to learn. But that's the great thing about this job.
Yep.
You know.
And it's water. It
Absolutely.
always changes. Well, thank you. Like, share.
Yes.
Repeat, like, share, repeat again, like, share, repeat, pass it out. Let us all know what you think, and then we will, I don't know what we'll talk about on our next topic. Are you doing another presentation?
No.
Oh. Do you want to talk about lead and copper?
No.
Oh. We'll figure it out and we'll
I
let
can.
everybody know.
I could talk about the next steps for lead and copper.
All right, there you go. That's our next topic. All right, we'll see you.
Have a great one.